Assalamualaikum.
Waalaikumsalam.
Assalam, miss. Good morning.
Good morning.
Good morning,
How are
Miss.
you, girls?
Fine, Miss. Alhamdulillah.
Okay. I hope you're studying physics. Now, do you remember in our previous class we were doing Ohm's law, and then we came till I think ohmic conductor and non-ohmic conductor, the VI graph. Do you remember that, girls? Okay, I hope you have the textbook and the note in front of you. And we came to, that is the VI graph, means the voltage and current graph in terms of ohmic conductor and non-ohmic conductor. Right, girls? And yes, girls. And we found in case of the ohmic conductor, the VI graph is supposed to be a straight line from the origin. And it means that the gradient of this particular graph will be constant. That is why we can expect a constant resistance in this particular type of conductors. Right, girls? Do you remember this point we have discussed in our previous class? Okay. Now, for the non-ohmic conductor, we found that the VI graph is not going to be a straight line. It will be a curve, and we found that it came out like it is going to be inclined to the voltage axis. If I keep voltage in the y-axis, then it will be x-axis, then it will be inclined to the x-axis. And if I'm keeping voltage to the y-axis, then it will go towards or inclined to the y-axis. And we found that it actually means that according to the graph, we can say that the resistance of that particular conductor will not be constant. It will keep on increasing. And it has a reason behind it because the temperature rises. According to that, the resistance of the particular material will keep on rising. Isn't it, girls? That was the point we last discussed about the non-ohmic conductor.
Miss, can you bring your mic closer?
Okay. Sound is low.
Yes.
Okay. Could you hear now? I'll be speaking out loudly.
Okay.
Okay. Now, our next point is electrical working. Now, first of all, we have to remember whenever we are having a circuit, electrical circuit, transfer of energy always goes from the power source, means it can be our main source, means the mains electricity, the one we are using at home, the one which is having a 220 volt as the source power, or it can be the cell or the battery, the one we use. So what happens over here, we remember that whenever an electrical energy is functioning, it transfers the electrical energy to other forms of energy. And it will go to the components, actually, the component which is connected to the circuit, and from the component, it will go to the surroundings. Now, if I just ask you or give you a simple example, it will be much clearer to you. Think about the moment you woke up from sleep, and then you just switched on the light of your room. You applied electrical energy to this switch, means the moment you switched on, your appliance, means your lamp is connected to the main circuit, means the mains electricity that is coming towards your home. And then from there, you are expecting some light energy. So electrical energy has converted to light energy. At the same time, you have to remember when there is a conversion of energy going on, certain amount of energy will be wasted. The one which will come out in terms of heat energy or the thermal energy. And definitely that thermal energy will be transferred to the surroundings. Okay, so we can say that whenever you are switching on the light, you are applying electrical energy to the lamp, and some light energy, of course, you are taking maximum amount of light energy, but some portion of the energy will be converted to heat energy. And then we can say that this is the conversion of energy going on from electrical energy to light energy, and some energy will be always wasted, that is coming out to the surroundings in terms of heat energy. Okay, guys. So now, as I said, that it is converted, some energy will be wasted, and it can be turned into light energy, it can be heat energy, as well as it can be kinetic energy. Means we are applying electrical energy that will come out in different types of energy after getting transferred to other forms. Okay, now, how do we actually calculate this one? For that, we need to know the power. What is that? The amount of electrical energy converted into other forms of energy per second is called power. So already we know the formula that power equals to energy over time. Means energy transfer divided by the time taken. So the power is actually P equals to E by T, and when you rearrange the equation, you are getting E equals to PT. Means energy that is transferred will be nothing but the power multiplied by the time. Now, if you just look at the next equation that I wrote, P equals, I wrote it, just rewrite the equation by taking Q inside. What is Q? Do you remember, girls? What is capital Q? Okay, Noor, are you there?
Charge, right?
Yes, it is the total amount of charge inside this particular substance. So we are writing E by Q into multiplication Q by Q. So you can see Q and Q is getting actually cancelled. So my original equation P equals to E by T remains the same. But I did it purposely so that I can derive another equation from here. I wrote E by Q. It is actually nothing but the voltage. We learned it before. In the initial stage of our syllabus, we learned it that E by Q is actually voltage. At the same time, Q by T, that is the current. So we can say P equals to VI, the new equation for the power. Power equals to voltage multiplied by the current. Okay. Now, at which amount or the rate at which the energy is transferred to an element like a lamp in a circuit is called power dissipation. Okay. Now, how to calculate that power dissipation? Okay. This dissipation thing we say is that getting wasted. Okay. Getting wasted. So, we are taking this one in the equation P equals to VI. So this V is actually IR. If you remember the Ohm's law that we discussed before, there we found V equals to IR. And then we have to multiply that one by I from our original equation number 2. Then it comes I square R. And in place of I, I'm again replacing V by R, substituting the value of I. And we're getting V by R whole square and multiplied by R. If you see, the final equation comes out, that is P equals to V square by R. Now, the work done or the total energy or the total amount of energy transferred can be calculated as follows. We went back to the equation number 2, that is P equals to VI. In that equation, we're going to multiply P in both the sides. Yes. Now, after that, look, P into T is actually nothing but the work done. We know that work. Yes, listen, girls. Work done is actually nothing but the energy transferred. We learned it before. Work done is equals to the energy transferred. So in place of P and T, I wrote W, and VIT altogether, I wrote VIT. So what is our equation now? As I said, work done is nothing but the energy transfer. We can say E equals to VIT. Again, we can say E equals to I square R and T. If you just look at it, in equation number 3, we wrote P equals I square R. So in place of P, we are just substituting the values of P. Equation is E equals to VIT. Then again, in place of P, I am writing I square R. Again, in place of P, I am writing V square by R. So we got 3 equations over here in terms of energy transfer. So E equals to VIT, E equals I square RT, E equals V square by R and T. These equations we'll be using many times to solve some problems. In the past paper 4, you'll find out lots of problems regarding this topic, and we'll be solving it by using all these equations. Now, I want you to tell me, girls, I hope you don't have any doubt in these equations. Did you understand? But you have to learn it. Means you have to memorize all these equations. First of all, what is the first equation we learned? V equals to IR. That's the Ohm's law. Then we used that one, and we found here P equals to VI. If you remember, in thermal physics, we used this equation few times. Remember, we learned E equals to PT. Again, we wrote E equals to VIT. That time I told you that when you come to this electrical... Nimra, could you switch off your mic, please? Yeah, it's creating noise here. Yeah, fine. Good. Thank you. So let's continue. As I was telling you, if you remember, in thermal physics, we had the equation P equals to PT, and there in place of P, we wrote VIT, depending on the quantities that is provided in the question itself. So now we came to that equation here. And we found that P is actually nothing but VI. P is the electrical power, and that is equal to the voltage of the source multiplied with the current provided by the voltage to that particular device. Okay. Now, I hope you don't have any other doubt in these equations. Guys, if you have
Miss,
any doubt,
I have a question.
say, please.
Can you please repeat that about the first one? I think yes, the first one, that P equals to E by Q into Q by T. Can you tell something? You said something about the Q, taking in the Q.
Okay, fine. Let me explain
The
it to you
charge.
again. Okay, yes. Africa, wait, I'm doing it again. First, as I said, what is this electrical power? We say the amount of electrical energy converted into other forms of energy. Other forms of energy per second is called the electrical power. Means it has to be in 1 second. As you know that second is the standard unit of time. So whatever we are going to calculate, it has to be in 1 second. So we wrote the basic equation, that is energy transferred divided by the time taken. So energy transferred, everybody knows it is E and divided by T. Then P equals to, I brought Q here just to find out another relationship between voltage and current. I wrote it E by Q multiplication Q by T. So that Q and Q is getting getting cancelled. So P is ultimately becoming V and I. And why did I found this equation? Because in some cases, we have to show the relationship between the voltage and the current. So I wrote E by Q purposely, Q as a denominator. And again, I wrote Q by T, Q as a numerator. So if you just look at it, Q and Q is getting cancelled, and my original equation, P equals E by T, remains the same. Isn't it, girls? So we wrote P equals to VI. Okay, I hope it's clear for you now.
So can you repeat that?
Okay. As I told you that we are writing the first equation as P equals to E by T. Now P equals, as I said, I'm going to bring Q just to show a new relationship between power, voltage, and current. So I wrote E by Q. This Q I just brought myself. Multiplication Q was a denominator here. Then I made Q as a numerator so that it will get cancelled automatically, divided by T.
Please.
But yes, we are saying E by Q is actually another term.
Thank you, Miss.
Yeah, you're welcome. Equals to V, and then Q by T is I, P equals to V. That. Now, anyone else having any doubt in any of this equation? I can see I got 19 students today, but as far as I remember, we have 32 students altogether. Isn't it, girl?
That's the equation P is equal to V squared by R into R. Can you explain that?
Okay, yes. So, Nashita, just check beside my equation. I gave a bracket and I wrote I equals to V by R. Actually, it is from the Ohm's law. We know that V equals to IR. From there, I just rewrite the equation and made I as the subject. So, I equals to V by R. And here, in the question number 3, see, I gave the name, equation number 3, I wrote P equals to I square R. In place of I am substituting V by R. And V by R is actually becoming V square by R square, isn't it? And we have another R as a numerator. So one of the R is getting cancelled. So it is becoming V square by R. Another equation for this power. Is it clear now, Nashita? Fine.
Yes, yes.
Okay, guys, I'll do one thing. Now it is only around 9:45. 10 o'clock or 10:15, I want to check the attendance because I can see only 19. It was supposed to be 32. What about the other subjects, girls, like math? Do you have all the students present, math, English?
Miss, some students are always absent actually.
Okay. In that case, okay, I have to check the names and I have to inform your husband teacher regarding those students because they're missing all these classes. Okay, fine. I'll check it after 10 o'clock again. But let's go to the next topic, that is electric circuit. Okay, and you know that circuit is a very important topic for our syllabus because without the circuit, a particular device or any component cannot actually function. It has to have a circuit. So what is a circuit actually? First of all, we have to say circuit is actually a route of electricity to pass through. Circuit is a path through which electron flows. There are 3 parts of a circuit. You have to remember that certain parts has to be there, otherwise a circuit cannot function. Number one, there has to be a source of electricity. It can be a cell, it can be a battery, it can be a generator. Now, I'm not sure you know about generator. In our syllabus, the next chapter we have, that is electromagnetism. There we're going to learn about generator. But you remember, generator provides us AC, means alternating current. By the time we learn about alternating current, so I think it will be easy for you to understand. Okay. Now, cell and battery is there. These two is going to provide us DC, and generator is going to give us AC. And we have to have a source of electricity all the time whenever you want to make a circuit. Then point number two, a device that uses electricity, means you have to have a component that will give you, that will use the electricity that you're providing from the source. What that can be? It can be a lamp, it can be a resistor, ammeter, voltmeter, and any other components. Now, let me remind you guys, here the points that we're writing, it's all about the laboratory procedure. We're not discussing about your daily life. It can be, if you discuss about daily life, then you can have a fan, you can have a table fan, you can have an electric heater, electric iron, so many things, right? But we're discussing about the laboratory procedure now. And point number three, that is another important part, because you have all the appliances, but you cannot connect them. So we call it a connecting wire. We are going to use it, wires that connect the components of the circuit. Mostly wires with crocodile clip is used to connect. Okay, crocodile clip is something like it. If you open it, it looks just like like the two jaws of a crocodile. And why it is made like this? So that it can hold the particular component tightly. It shouldn't come up. It should not slip. That is why we use the crocodile clip. Inshallah, if our school, we are going to school, I'll show you all these components. We do have them in the laboratory. I will show you.
Can you speak a bit louder? Your voice isn't clear enough.
Okay, I'll speak up more loudly. Is it clear now to you guys? Anuj, could you hear me?
Yeah.
Okay.
Yes, miss.
Okay. Now, let's go back to that point again. Connecting wires, as I said, we need to have a connecting wire which will connect all the components of our circuit. As I said, what are these wires actually made up of? These are...
What are the components again?
Component means it can be a lamp, it can be a resistor, ammeter, voltmeter. These are called components. Means all the appliances, components, appliances, you can say device, we can give many names to them. Okay. So to connect them, we need to have certain wires, and those wires are actually nothing but a copper wire. Simple insulating copper wire. Means we should have an insulation on the top, and at the end of the wire, there has to be a crocodile clip, which is going to hold the particular device nicely, so that we should have a particular consistent connection all through the practical or all through the experiment. Okay. Now come to the next point, that is open and closed circuit. The next one is now open and closed. 2 points we can understand. Open means there is not a complete path of electricity in this particular circuit. Means one of the part is open, means one of the wire is not connected properly. That can be, means there is not a complete path for the electrons to move all through the circuit. That is called open circuit. So in another way, we can say open circuit is the one which actually doesn't create a particular path of electrons and will not get any reading from there because it's not functioning. And what is the closed circuit? When it is completely, all the connections are completely done and there's a complete path of electrons flowing all through the circuit, we call it a closed circuit. And we say that time we are going to get a reading if you have connected an ammeter or a voltmeter, you're going to get a reading from there because it's a closed circuit now. Now, let me remind you one more thing here, girls. Whenever we are going to connect a circuit, we have to ensure that we should have a switch over there all the time because you should have a control on the circuit. When you apply the switch, if you switch it on, then electricity is flowing through it. When you switch it off, you can stop the electricity flowing through it. If you remember, in Ohm's law, we discussed many times that switch on the circuit in between the readings. We wrote that one as a precaution. Means you are having the control of the circuit and you can switch it on whenever you feel like, and whenever you feel like, you can switch it off because you have the control on this. And we cannot have a continuous flow of electricity in a circuit for a long time. that will increase the resistance of the particular device or particular appliances that you have connected. And that will change the whole reading. And that can lead to us a wrong answer, wrong result. That is why you need to be very careful. That is why you have to have a switch in your circuit. Okay. Now I want to, because do you have any doubt regarding open and closed circuit? Anyone having a doubt?
No.
Okay, let's go to series and parallel circuit. By the time when we discussed about the series and parallel connection of the resistors, we got the idea that what type of circuit is called series circuit and what type of circuit is called parallel circuit. Okay. Then, now we can say one more thing, that is, when we have a connection like this, a series and a parallel circuit, first of all, in series circuit, we have to ensure that all the components are connected one after another. Means they are connected in a sequence, we call it one after another. If you just look at the diagram that I have given to you in my note, there we have shown that there's a source. Okay, now if you remember, I told you in the class that the symbol of the simple or a single cell is like a long line and then a small line, a short line, like this we draw. The long line represents the positive terminal of the cell and the short line represents the negative terminal of the cell. Then from there you can see, if you just omit, right now don't consider or emitters, voltmeters, nothing. First you just check, from there positive terminal, it came out and it has connected to a lamp, from there another lamp, and from there another lamp. After that it came back to the switch, from the switch it came to the negative terminal. So this is a complete path of electricity or electrons that we have provided. And now, after that, if you just look at it, across each component, here how many components we have? Here we have a source of electricity, we have 3 lamps. So across each component, we have given a connection of a voltmeter. And whenever we give a voltmeter across the particular appliances, we actually try to measure the voltage across that particular appliance, not the whole circuit. Okay, girls? And we already mentioned before that this type of circuits, the one we are discussing right now, series circuit, is actually known as a voltage division circuit, where whatever voltage is provided by the source will be getting divided among all the components that is connected in the circuit. Okay, then what we did, another thing we did, we placed certain emitters in certain places to measure the current flowing to each appliance. All of you just look at the first emitter that I have placed immediately after the source. I placed an emitter in the series. And do you remember that we have discussed emitter should be connected always in series? Do you remember that, girls? Okay. So,
Yes, ma'am.
yeah, fine. Now let's continue from there. And that is why just immediately before the first lamp, the one we can say lamp 1, from before the lamp 1, we have connected an emitter. Then before the lamp 2, another emitter to measure the current in lamp, the second lamp. Like this, we placed 3 emitters. At the same time, we also placed an emitter immediately after the source in series to measure the total current provided by the source itself. But we know one more thing, that in a series circuit, current actually never gets divided. The current that is provided by the cell or the battery or the source of electricity will be proceeded to all the lamps that is inside the circuit or all the appliances that is connected in the circuit. So I wrote in point number 1 that in a series connection, current is same throughout the circuit. Then I wrote I, that is the first one that is coming from the lamp, that is coming from the source, that I will be equal to I1, the current that goes to lamp 1. That will be also equal to I2, the current in lamp 2. That will be also equal to I3, the current in lamp 3. It means that all through the circuit, the current remains the same. You will see, girls, afterwards when I solve the past papers with you, they'll give us a big circuit, and from that circuit, we have to show the relationship between the currents. How do they actually get divided? And of course, they'll be giving us a mixed circuit with a series and a parallel together. But right now we are discussing about only the series circuit. So remember the first point, that the current never gets divided. Current remains the same all through the circuit. Okay. Now let's continue point number 2. As I already said, it is a voltage division circuit. So the potential difference across the source or supply is equal to the sum of the PDs across the components. And what does it mean? If you just look at the diagram, the voltmeter V that is connected across the source is going to give us the total voltage from the main source. But that voltage will be getting divided among all these components that is connected. And here components are all lamps. Even if I don't know whether the lamps are identical or not, but we can say whatever the resistance of the particular lamp is there, the voltage will be according to that. Because previously we discussed a little bit about it. Even afterwards also in the electronics chapter we'll discuss again. We call this circuit as a potential divider circuit. If you remember in my previous class, I mentioned this one to you. Do you remember that, girls? In my previous class, I mentioned that this circuit is also known as a potential divider circuit. Do you remember that? Fine.
Yes.
Fine. Okay, Noor, tell me one thing. You had my previous 2 class with you when I was there. I was taking the class. You were there.
No, miss. I was almost there, but I couldn't make it.
Okay. That's why I was thinking that I haven't seen you on my class in the previous 2 days. Okay, fine. So now, after this, let us go to the next point. As I say, if you just look at the diagram, so the main source, whatever voltage it is provided, V, that will be equal to V1, that is the voltage for the first lamp, plus V2, voltage for the second lamp, plus V3, voltage for the third lamp. So when we do the calculations in the exam paper, they'll give us a circuit, and first we have to understand whether it is a series or parallel. From there, we'll decide which equation I'm going to use to find out the particular quantity. Right, girls? Okay. Now, I wrote something more over there. Potential difference across each device is proportional to its resistance. This is the point which is actually coming from that potential divider circuit, as I said. The more the resistance, the more the PD. Think about, I have 3 lamps that is connected the way I have given you the circuit. That is connected to the circuit, and they have different resistance. Among them, the highest resistance is 10 ohm. So I have to say that this particular lamp with a resistance 10 ohm is going to get the maximum voltage from the circuit because it has the highest resistance. The more the resistance, the more the voltage. Okay. Now, I wrote something after there. Series connection is also known as voltage division circuit. I mentioned to you before also that always will remember current remains the same, voltage gets divided. So it is a voltage division circuit. Is it clear, girls? Anyone having doubt in this particular series circuit?
No, miss.
Very good. Okay. I can see Tajian. Tajian, do you have any doubt over there? Tajian, are you there? Are you following my class? Yeah. Do you have any doubt?
No, it's okay. It's clear.
Very good. I want to ask, I can see Habiba. Are you following my class? Habiba, are you there?
Yes, miss.
Okay. Did you follow this circuit that I have given to you? Is it clear to you, the series circuit that I have discussed with you right now?
Yes.
Okay, fine. Now I want to ask Ikra. Ikra, how are you?
Yes, miss.
Yes.
I'm
How are
fine.
you, dear? Okay, fine. Is
I'm
it
fine,
clear to
miss.
you? The circuit that I have
Yes, miss.
discussed with you? No doubt, right?
Yes, miss. No.
Oh, that's really good. And I can see Fatima, right? Fatima to Zohra, right?
Yes, miss.
Okay. How is it for you, the circuit? Is it okay? The way I discussed
Yes,
with you?
teacher.
Don't know.
It is okay.
Yeah, you don't have any doubt, right?
No, miss.
Okay, very good. So let's continue to the parallel circuit. All of you first concentrate on the diagram, the circuit diagram, the way I have given to you. If you just look at here, I have given you 3 lamps, just like before the 3 lamp, we had the series circuit. Here also, I use the same components so that you can have easily a comparison between these two. We have connected the 3 lamps and they have a common point. If you just look at them, they have a common point, and those 2 common points came to the source again. If it is like that, we can understand if you just look at the diagram from the, okay, before that, I want to ask a question to, okay, Sumaya, are you there?
Yes, Miss.
Okay, I want to ask you a question. Could you tell me what is a conventional current flow? Because we are going to discuss about it right now. Do you remember what is a conventional current flow?
No.
Okay, then who can help me? Is there someone? Okay, I can say Muntaha. Are you there? Muntaha, do you remember what is a conventional current? Muntaha, are you following my class? I think she's not there. Okay, Asil, are you there?
Yes.
Yeah, Muntaha, would you tell me the answer about this one? The question I asked you. What is a conventional current? Muntaha?
I don't know.
You have to go through the notes and the book as well. Okay, Asil, could you tell me what is this conventional current? I think we discussed that day. Okay, is there anyone who can give me this answer? Conventional current. What do we mean by that? Hello, girls.
The flow of current from the positive charge to the negative charge. It's like when electrons flow, the current
Okay.
also flows the
Yes.
opposite direction.
Okay, Afnan, I wanted to give you full mark, but I have to cut 1 mark from you.
Eh.
You know why? You know why? Because you said positive charge to negative charge. No, dear. It is positive terminal to the negative terminal.
Yes,
Yeah.
sorry.
Yeah, it's okay. So you'll remember that. Okay, fine. It's good that you still remember this one, but it's a basic thing we have to remember all the time. Okay, now let's go back. As I said, if you just look at the diagram, from the positive terminal of the cell, I have given a connection of an emitter. From that, when the 3 branches came out for the 3 lamps, we placed one emitter over there. At the same time, across all these 4 components, means the cell and the 3 lamps, we again placed 3 voltmeters, so that we can measure the voltage across all the lamps along with the source. If you just look at this diagram, first thing I have to say, as we learn, the series circuit is a potential divider circuit or a voltage division circuit. So definitely we can understand the other circuit will be a current division circuit. This is the basic difference between these two circuits. In parallel circuit, the current actually gets divided according to the components that is connected there. But the voltage remains the same. So if we just look at the diagram, first thing we can say, current from the source or in the main circuit, means from the source it can be a cell or battery, or from the main circuit means 220 volts, the one we are getting. In the main circuit is equal to the sum of the current in the branches. In my diagram, if you just look at it, we have 3 branches. So what I did, I wrote I equals I1 plus I2 plus I3 because I have 3 branches. So whatever current is coming out from the cell, it will get divided into 3 branches. I1 plus I2 plus I3. Okay. Now, as I told you before, it is a current division circuit. So what will happen to the voltage? Definitely, the voltage will remain same all through the circuit. All the components is going to get the same voltage. So we wrote it here that current to each component depends on its okay. But before that, just hold on one second. I was telling you about, let me finish the current part, then I'll go to the voltage. As we said, current is passing in the individual part followed by the individual components that is connected in the circuit. So whatever current is passing through each component, it will depend on the resistance of that component. Just imagine among the 3 lamps, one was having 10 ohm resistance, just like the example I gave you for the series circuit. Then this 10 ohm is the highest resistance we see. So could you tell me, will it get more current or less current? As it is having the highest resistance, will it get more current or less current? What do you think? Girls?
Less current.
Yes.
Less,
Definitely
less
less.
current.
Yeah, that's the correct answer. It is less current because the more the resistance, the less the current. So we wrote it that so each component depends on its resistance. Now, if we just compare this one with the series circuit, there we learn the one component which is having highest resistance will receive more voltage. and here less current, isn't it? Completely opposite to each other. Okay, now come to the point. We say parallel circuit is also known as the welcome back, girls. Please connect quickly so that I can continue with my class. Thank you, girls. Okay. Okay, now I was there in the parallel circuit I was discussing with you, and I was telling you that it is a current division circuit, right, girls? Now, come to the point number 2, where we are saying potential difference across each component is same as the supply. Now, first thing, as I told you before, that yes, girls, please connect yourself. Yes. Okay. Now, potential difference across each component is same as the supply. So V equals V1 equals to V2 equals to V3. If you just remember, I told you, think about, I have a cell that is connected to all the lamps is having a voltage around 10 volt. So this 10 volt will be used by all of them. All the components that is connected in parallel circuit is going to have the same voltage, that is called 10 volt. Means voltage will not get divided here. Only the current will get itself divided according to the particular roots or the branches we call it. But here the voltage will remain the same. Okay, done. Now we have to know which circuit we are going to use. Okay, guys, all of you please switch off your microphone. Yes. Advantages of the parallel circuit. Now, for that, I want to tell you guys, means in our daily life, where do we actually see the series and the parallel circuit in our daily life? Means in our home or some other places, where do we actually see that? If we just consider your home initially, we can say that all the lamps that is connected in our home are all in parallel circuit. Okay, why? I'll tell you afterwards. And point number 2, where do we see the series circuit? Okay, the series circuit mostly we get, the decoration lamps during the Eid time or any festival time, the shopping mall and some buildings, they do decorate with the small tiny bulbs. Okay, those are the series connection. Now you tell me, what is the brightness of those lamps? Is there someone who can tell me the decoration light that is used to decorate a shopping mall or a building during a festival time? What is the brightness of those lamps? Could you tell me, girls? Is there anyone who can tell me?
I think the brightness is low.
Very low, in fact. The brightness is very low. And
because of the PD, right?
Yes, yes. The less the voltage, less the brightness. And think about your home. In each and every room, we do have a separate lamp. And if you just notice, if the lamps are all of same power, definitely you'll be getting the same voltage all through and the same brightness. So we're coming to the point. We wrote, this is the advantage of a parallel circuit actually. Each device gets the same PD as the source. Means if we are using 220 volt, of course in this country we have another voltage that is 110. But if you consider only 220 volt also, we are getting 220 volt for all the lamps or all the appliances that is connected in our home. That is why each and every room, the identical lamps you are using, you will get the same brightness. There will be no change in the brightness. Point number 2, each device can be turned on and off independently by connecting switches. It cannot be like that you switched off your drawing room light and your bedroom light is also gone. It never happens like that, right, girls? So it means that we have all the connection of the lamps or any other connection in our home, all are in parallel. They have their separate switch, separate branch, so that you can switch on and off whatever or whichever light you want to, you can do that, right, guys? So this is point number 2. Another point we remember, that is here all the device or all the components that is connected in parallel circuit is always getting the same voltage. So there will be no change on the voltage, only the current is getting divided, but we are getting the same brightness just because the voltage remains the same. Now after that I wrote some of the points which you have to remember, because when we discuss the circuit, we have to understand in which circuit, what are the advantage and disadvantage we are getting. And you'll be getting some questions regarding this topic. So it's important for you to understand. Point number 1, see, series circuits are basic types of electrical circuit in which all components are joined in a sequence so that the same current flows through all of them. Already we discussed it, but here we wrote it in terms of points, that what is actually happening. In series, we are giving connection one after another, just like a sequence, and all of them are getting the same current. Okay. Now, I want to ask you one more thing, guys. Those decoration lights, just imagine one of the lamp is not functioning anymore. So what do you expect? Will the other lamps will still be shining or they will go off? What is your idea, girls?
They'll go off. They'll go off
Definitely.
because it's series.
They'll go off,
Exactly.
yeah.
Yeah, correct answer, girls. Thank you. So you are getting used to all these differences between the two circuits, right, girls? Very good answer. Definitely they will go off because if one of the lamp is not functioning, means the circuit is not completed here. It cannot complete the circuit. There's a broken part of the circuit because the lamp is not functioning. But in case of parallel, if it happens, the rest of the lamps will still functioning or still shining. Okay. So next point we wrote, parallel circuits are type of circuits in which the identical voltage, means same voltage, occurs in all the components with the current dividing among the components based on their resistance. We discussed this point before. As if the resistance is more, it will get the less amount of resistance. If the resistance is less, it will get more amount of current. It depends on the resistance of the particular device connected in the parallel circuit. But the current will get divided. In point number 3, we are saying in series connection, the circuit will not be complete if one component in the circuit burns out. The one I discussed about the lamp, if one of the lamp is not functioning, so the circuit is not complete. So the rest of the lamps will also not shine anymore. In parallel circuit, will still continue to operate at least with the other components if one parallelly connected component burns out. Means in parallel circuit, if 3 lamps, think about something happened, your drawing room light is not going to shine anymore. It's not shining anymore. Doesn't mean that the other lamp will not shine. They will still function. Just because they have a separate route or path to complete the circuit. So, now the last point we wrote, which is very important to us, as I told you, we already discussed about it. In series, potential difference is shared. PD is shared, so lamps are dim. As I told you, in all those decoration lamps that we see all the time, those are always dim. And in parallel, each lamp gets the full PD, whatever the source is that. If it is 110 or 220, then all the lamps will be equally bright. Okay, guys? Now, you just tell me, in this full discussion that we have had right now, do you have any doubt in any particular point or topic? You can ask me now before going to the next diagram.
Miss,
Yeah,
can you repeat
which one?
the points to remember number 2?
Number 2.
Number 2.
Yes, sure. I'll do that. Okay, now listen. In point 2, we wrote, parallel circuits are type of circuits in which the identical voltage, identical means same, identical voltage occurs in all the components. No matter how many components you are connecting, all of them will get the same voltage. Means in our home, no matter how many lamps you have, 20 lamps even if you put, all of them will get 220 volts. Okay, with the current dividing among the components based on their resistance. Now, it's not necessary that all the lamps are going to have the same resistance. They can have different types of resistance, less, more. It can keep on differing from each other. But we are saying in that case also, the voltage will remain the same, but the current will keep on changing according to their own resistance. We say if the resistance is more, the current will be less, but it will still show the same brightness. Okay, because we are having the same voltage. Okay. Now, after that, see girls.
But Miss, in series circuit, will the brightness differ?
Brightness will become always dim. In series circuit, you cannot, yes, if you just connect one lamp, that time you can expect it will be bright. Because only one lamp is sharing the PD, but if you join more, like think about you, in place of one, you place 20 lamps, then all of them will become very dim. We can never expect bright brightness, bright light or brightness from the lamps which are connected in series. And that is why, you know, all those decoration lights are connected in series, not in parallel. Because we don't need to read book over there, isn't it? We don't need to see each other. It's just the decoration light. Okay, fine. Now, all of you check, I have given you a task. Actually, it is a task. I normally give the students to solve it. But since we cannot have a regular class, so I gave you the note along with me. Now, you just look at the diagram. It's a past paper question. In the question, they told you, in your apartment, you have two 100 lamps in your living room. Okay, the drawing room, the one we call 100-watt lamp. Okay, now let me ask you one thing, girls. What? Which quantity is having this unit? Watt? Who can tell me which quantity is having the unit? Watt? I wrote 100 watt, 200 watt, 60 watt. Which quantity is represented by what?
Power.
Yes, definitely. It is power. It is power. And by the way, do you know the name of the scientist from whose name we are using watt?
What?
Of course, Watt, but what's his full name? Anybody knows his full name? James Watt. Yes. Okay.
James.
Yeah, James Watt. He invented that engine that is with the what do we call it? After boiling the water, we get the paper. With that, he invented the engine. Okay, when he learned it, and then he invented the engine. Okay, now, so 100-watt lamp in the bedroom, 160-watt lamp in the washroom, and 100-watt lamp in the kitchen. So this is your flat, the arrangement they gave you. There has to be 2 lamps in the living room, 1 lamp in the bedroom, 1 lamp in the washroom, and 1 lamp in the kitchen. They're asking you to draw a circuit diagram so that now they're applying the conditions. What are those? So that there is 1 switch for each room. Okay, it means that you have to provide each room a single switch. Okay, and 1 master switch that will turn off all the lamps. And there has to be 1 master switch as well. And one more thing is that they say, okay, the switch that will turn off all the lamps, label all the lamps with the power. Of course, they have different power, so you have to label it. And consider all the lamps gets the same peak. Now, forget about the diagram. If you just read the question, what thing comes in your mind, first of all, that which type of circuit you have to draw? Will it be series or parallel, or which condition you'll be drawing it? I want
Parallel.
to say, Asil. First thing,
I said
comes
parallel, miss.
it is parallel. Of course, you have the diagram in front of you. But first, you check with this point. We wrote here, consider all the lamps gets the same PD. That is the point which leads us to parallel circuit. Same PD. That is happening only in case of parallel circuit. Okay. Then what we did, and they mentioned that each room should have a single switch. So, and did you notice here the way I view the source? What is the symbol? Which type of source we are showing here? Guys, who can tell me which type of source is this? The one I view over here?
Open switch?
No, dear. Anu, could you tell me? I'll give you the answer.
It's AC, right?
It is AC.
Or
AC is like 2 holes over there, 2 circle, and in the middle there will be a wave. So it means an AC source. Of course, you have to have AC in your flat. Otherwise, with DC, it will not function. DC can provide us a very low voltage. AC we need, that is 220 or 110. Of course, the home line in all over the world, every country do have their 220. Only in this country, we have another line that is 110. Now, from 220, did you notice I gave a switch initially? Which condition is this one there? Could you read the question and tell me why did I put that switch immediately after the source?
The master switch.
Very good. That is the master switch. Means, think about you are going to sleep at night. You cannot just go to each and every room and switch it off. You just switch on that one, switch off that one, then all the lamps will be off. We call it a master switch, the one which can operate or which can control all the lamps at a time. Okay. After that, just look at it. You see there are 1, 2, 3, 4 branches because we have 4 rooms in that particular flat or apartment. So if you just look at it, on the first floor, we wrote on the first room, they say there has to be a living room with 2 lamps. So we gave parallel connection to both of them. And you know, most of the students, what mistake they do? Over there, they just put them in series. But if I put them in series, what problem I can come across, girls? Could you tell me? If I put the 2 lamps in my living room in series, what problem could be there?
As you said, both will be turned off. Like if one goes off and the
No,
rest
no,
switch.
no, dear. Because I'm giving only one switch. Definitely, if I switch it on and off, both will be off.
Okay, okay.
There will be dim, less bright.
And could you repeat? I didn't understand.
There will be less bright.
Yes, yes, both, because that time they will be less bright, at the same time they will be sharing the voltage. They will not get the equal voltage. In the question they said all the lamps should get the same PD. So we cannot give a series connection there. It has to be a parallel connection. Otherwise your condition will not be fulfilled there. Okay. Now come to the other rooms. They have a single lamp, so it's not a problem here. Each room we take up to 1 switch and we have given connection all of them. But only that living room part you have to be a bit careful. Where we are going to get two lamps which are connected in parallel. And what is the purpose behind it? Because we have to ensure both the lamps are getting the same voltage. Okay, guys? Okay. Now, I hope you don't have any doubt regarding this circuit, because in the exam paper, they'll give you some condition and you have to check. Okay, girls, now I can see my participant of students moved up to 20. So, girls, could you please help me? Who are the girls not present in my class? I just want to write the name so that I can inform your homeroom teacher.
What, miss? Can you repeat?
Yeah, could you help me by telling the names of the girls who are not in my class right now?
Okay.
Yeah, please help me.
There's Reem, I guess. She's not here.
Okay, Shahad Reem, right?
And
Shahad.
Jane as well.
Reem is here.
One by one, please.
Oh, Reem is here, miss.
Reem is here, miss.
Oh, okay, fine. Reem is there.
Sadia Hassan.
Okay, and Luzain is not there, right? I didn't see, 1 minute there. I didn't see Shahad and Luzain in my previous class as well. Do they participate in any of the classes?
Sometimes they do.
But I don't know why they're doing like this. They have to participate in all the classes. Okay, fine. And who else? You said Sadia Hassan, right? Okay. And,
Yes.
And
Some.
Afnan Laiba, I couldn't see today.
And Marwa.
Marwa. Okay. And then I can't see Ibtisam as well, right, girls? Okay, because it's 20, it was supposed to be 32. 12 girls are missing. And who else?
Nafisa.
Nafisa. Okay. Nafisa. And then? Do you think these
Is
girls
Asiya
are
present?
No.
Warda.
Asiya, Warda, yeah, I can't see any of them. I don't know. Is it like they're sleeping? But yesterday night only I gave this information to you, message that I'm having a class with you today. No, this is not good. They are supposed to be here. Okay, who else here?
Sadia Hassan.
Yeah.
Sadia Hassan, I think we got, no, it's supposed to be 12. Yeah, I got 10 girls thing. 1, 2, 3, 4, 5, 6, 9, 10, 12.
Is Afnan here?
Afnan Abdul Karim.
No,
is
she
here.
isn't here.
Afnan Laiba is not there.
Oh.
Okay, then who else? Okay, I can't see.
Sarah.
Yeah, Sarah. She was there in my previous class, I remember. Sarah. Okay.
Rahma.
Rahma, miss.
Even Rahma, yeah. In my previous class, Rahma was. Ibtisam I wrote, yeah. Because Rahma was asking many questions to me in that class, but today she's not here. I don't know. But you do follow all the messages, right, girls, all the time?
Miss Sumaya is not.
Yes, miss.
No, Sumaya is here. She spoke to me as well. Sumaya, are you there? Yeah, she's here.
There. Oh, is she?
Yeah, she's there. Yeah, I can see Yampa. Yeah, that Rihan is there. Okay, fine. I think this many guys. Okay, guys. Now, since we have 5 to 6 minutes, before going to mains plug, I want to discuss this particular topic in my next class. But I want you to tell me, do you have any doubt? Because I might need one more class to complete this chapter, and then we can start solving all the past papers. And you know that in paper 4, almost every single year, not almost every single year, we do have a question from this current electricity, which is really, really important. And you have to understand the circuit. Along with that, you have to understand the equation, how to solve and find out the particular quantity. Okay. Now, just tell me, girls, do you have any doubt in any particular topic from the beginning? You can tell me from this particular chapter. Because
Can you tell what's red terminal and black terminal?
okay, fine. Now, actually, it would have been really good if I could show you all those components or the appliances personally means in the class, but since we can't have, so I'll just explain to you. You remember all these components that we have, like ammeter, voltmeter, electrical cell, the one that we have, they do have always two terminals. One has to be positive, another one a negative terminal. So when we have these two terminals, to identify all the time, it's kind of difficult for us to check which one is positive and which one is negative. So what they did, universally, we have decided that we are going to paint two colors. We are going to use two colors so that whoever is doing the practical or using all these appliances, they should easily understand which one is the positive terminal and which one is negative terminal. And they have decided that all the components, no matter which component we are using, ammeter, voltmeter, or whether it is a cell, we are going to make the positive terminal as red color. And the negative terminal should be black color. So that when we give connection, we can easily identify which one is positive and which one is negative. So you remember the positive, and especially it's very important, you know why? Because when you give the connection from positive to negative, if you just change it, it might damage your particular component. So we have to ensure that ammeter, as we learned, ammeter and voltmeter, positive terminal of those should always go to the positive terminal of the cell. So it has to be positive terminal, red terminal to the red, and black to the black, means negative to negative. If you give other way the connection, the particular component means the ammeter or the voltmeter might not even work. They will not actually work. They have to be positive to positive, negative to negative. Okay, and we have decided positive will be red and negative will be black. It is decided all over the world. Is it okay now?
Miss,
Yes, dear.
Miss.
the electron flow is always from positive to negative, right?
Current flow or conventional flow you're talking about?
The electron flow, current flow.
Yeah, current flow. Conventional current flow is from positive to negative, and we'll be following it all the time. But we'll remember that actually the real thing that is happening is the electron flow. That will be always negative to positive. You'll see one of the questions is there in the past paper, we'll do it. The question it will be mentioned that with an arrow in the following circuit, show the electron flow. Then definitely you have to show it from negative to the positive terminal because that is electron flow.
Miss, can you tell me the difference between conventional flow and current flow?
Okay.
In shortcut.
In short, okay, fine. First, you'll remember, actually, what is this cell doing? It is providing us electricity. And how it does that? It allows one of the electrons from the negative terminal to come out and go through the circuit and come back to the positive terminal. Okay, this is the main thing. But when we do the practical, that time we have to discuss that the direction we follow is from positive to negative, which is not happening, you know that, but we are just going to consider that one in our case. And all through the syllabus, we will always say we are following the conventional current flow. So you just remember both of them are completely opposite to each other. Conventional current flow, positive to negative, and the other one, negative to positive. Okay, dear?
Okay.
Anyone having any other question? And girls, it's really good to have all of you, but I want the maximum presence in my class. So should you inform the rest of your friends, like Varda, I remember she was in my previous class. Just inform them that tomorrow again you have the timetable, right, girls? Your teacher has given to you.
Yes, miss.
So everybody knows. And waking up 9:30 is not a big deal here. And I don't know how long we could sleep. Right? Now, since we're not having any school, if the school was there, we were waking up very early, 5 a.m. in the morning, and you used to do the same. Now it's 9:30, so I can't expect that my students are sleeping at this hour. Okay, fine. Now, I want to conclude my class today, guys. Inshallah, tomorrow, from here I'll continue, but one small homework I want to give you, that is, since tomorrow will be the end of this lesson, I want, or this chapter, I want all of you to go through thoroughly the full chapter. And then you'll tell me your doubts tomorrow. So that next week I can start my past paper, paper 4 specially. Right, girls? Will you do that?
Sure, miss.
Thank you so much.
Inshallah, miss.
Allah Hafiz and Assalamu alaikum. See you tomorrow, guys.
Walaikum salam, miss.
Assalamualaikum, miss.
Assalamualaikum, miss.
Bye.